Hello everyone, welcome back to Chemistry JRFnet. Today we are discussing how to classify the boranes into closo, nido, arachno and hypoboranes. The general formula to find out the closo borane is BnHn plus 2, or we can write VnHn2 minus, and the number of skeletal electron pair is n plus 1, and in nido BnHn plus 4 and n plus 2. Arachno Bn Hn plus 6 and n plus 3, and in hypo Bn Hn plus 8 and n plus 4 skeletal electron pair. The first question is B6H8. First of all, we have to find how many BH unit are there. Here boron is 6, so hydrogen 6 plus 2 here. So there are 6 BH unit, BH 6 and HX. X is the extra hydrogen. So we can write B6H6 plus 2. It is of the form BnHn plus 2, which can be also written as B6H6 2 minus. This is closo structure, and the number of skeletal electron pair can be found out by n plus 1. Here n is 6, so 6 plus 1 is equal to 7 electron pair. Next one is B4H9 minus. Here there are 4 BH unit and 5 extra hydrogen, and also 1 negative charge is here. So this also can be considered as hydrogen. So we write like this B4H10. Then we can separate as B4H4 plus 6. This is of the form BnHn plus 6. The structure is arachno. And the number of skeletal electron pair can be found out by n plus 3. Here n is 4. So 4 plus 3 equal to 7 electron pair. Now we are discussing the acidity of boron clusters. Greater the size of the cluster, greater will be the acidity. For example, B4H8, B5H9 and B6H10 are given, and the order will be B6H10 greater than B5H9 greater than B4H8. That is, greater the number of boron atom, greater the size of the cluster, and greater will be the acidity. And moving on to the stability order, that is, closo boranes are more stable than nido and arachno and hypo. This is the order. Next we are discussing the isolable analogy. Here in a cluster, isolable groups can be replaced by heteroatom. So instead of BH and BH2, this can be replaced by the heteroatom, carbon, nitrogen, oxygen, etc. So how can we find these heteroboranes as closo, nido, arachno? Let me check. So first of all, what do you mean by an isolable fragment? If two species are having same number of electron deficiency, it can be called as isolable fragments. For example, here we are taking the carbon. Carbon have a valence electrons, 4 valence electrons, and in case of BH also, BH have a boron have a 3 and 1 electron from hydrogen, so 4 electron. So it needs 4 electrons to complete the octet. So both these species having the same electron deficiency. So these are called isolable fragments. So instead of a BH unit, we can replace it by carbon. So for example, and this is a heteroborane C2B9H12 minus. So instead of C, we can replace it by BH. So we have written here BH twice B9H12 minus. That is B2H2B9H12 minus. So B2 plus B9, B11, H2, H12, and also 1 minus is here. This can be taken as a 1 hydrogen. This we have already discussed. So H2 plus H13, H15 here. B11, H11 plus 4, which is of the form Bn HN plus 4 correspond to nido structure.